So recently I've been reading about research that Ivar Mendes is involved with at University of Saskatchewan, who used to be here,
Yes.
around stem cell research to
Yes.
encourage new growth of the cells that produce dopamine. Can you
Yes.
speak to that at all?
Okay. What I can say is that that was brought to my attention, as a matter of fact, just as recently as last evening at the Dartmouth group. Someone gave me a little piece, I guess it was taken from some kind of document that was being circulated. I don't know anything specifically about that. What I can share with you, however, is that there will come a time, Carrie, and all of you, I believe, when stem cells will be made available for sure for many different kinds of conditions. Where the stem cell research, of course, is going on, it's ongoing for people with Parkinson's right now as we speak, which you've already indicated. The problem with stem cells is, well, there are a few problems, but let me just give you a couple of examples. First of all, stem cells obviously have to be inserted into the brain. The problem that they're having right now is that they don't have any problem getting a stem cell to know that it's supposed to produce dopamine. Let me back up the train for a second. Stem cells are basically cells that we all produce, we all have in our bodies, that are babies, and they don't know what they want to be when they grow up. So what the researchers have been able to do so far is to put those cells in petri dishes in labs, and they've been able to instruct them to be either heart muscle cells, to be cells to produce insulin, and they've also taken some cells and said, okay, this is what you need to do. We want you to be a dopamine producing cell. That's great. We've got that one down pretty pat. However, now we have to train the stem cells to do what we want them to do. And we have to be able to put them into the brain in exactly where we want them to go. Right now, we don't have a way of being able to do that. Right now, when we put stem cells in the brain, they don't always go where we haven't found a foolproof way yet of being able to get them to where we want them to go, to grow. So that's problem number one. That will be fixed one day, but right now we haven't been able to target being able to get them to where we want them to go into.
I think I read that part of his research is related to the mapping.
Yes, and that's very true, and that's very exciting. So that is a very exciting advance in research. There is another problem, however, that I think is very important for you to understand about stem cells. Stem cells have been implanted in the brains of people with Parkinson's in the past.
Mhm.
However, we as human beings are made up of what I call accelerators and brakes, checks and balances, so that when one thing happens and it gets out of whack, there's another part of our body that is able to kick in and be able to say, no, 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 we have to put the brakes on this one. And as a result, what we have is called homeostasis. That's when basically things are normal within our bodies. The problem with stem cells, however, is that when they were injected into the brains of people with Parkinson's, they were like Duracell bunnies. They produced dopamine all right, but they kept going and going and going. And for any of you who have an understanding of anatomy and physiology, when any cell in the body gets out of control and grows too much, it's cancer. It's malignant. So you don't want to have Parkinson's and a tumor. So we have a lot of exciting research into stem cells. I agree that Dr. Mendes's research is very promising, but to be able to say that it's going to be available in the near future is not something that I feel I can be honest with you about and say that's just around the corner. It's hopeful, but it's something that's we're going to have to wait on a bit. Does that help to answer the question?
Yeah, it's helpful to understand how it works. Thank you.
Okay.
In the article that I read, which I can send the link to Peter to share with the group and with you if you're interested.
Yes, I would be.
And I don't know anything about this. I bow to your greater knowledge than I have. But he was quoted as saying that they were hopeful that clinical trials might be available in the next few years.
Okay. So that I agree. When we say the next few years, however, that may mean 10 years from now. It may mean 5 years from now.
Yeah, he said 2 to 3.
Okay, fair enough. And that may start. And that may start. And that's great. That's very exciting and very promising. I'm not trying to be a bad news bear.
Yeah.
I just don't believe in not telling people the truth, because reality is that, you know, for any medication, whether it's even something that you can buy over the counter or that needs to be prescribed, a lot of people don't understand how many billions, and I did say that with a B, billions of dollars, that it takes to bring a new product to market. It takes billions of dollars, and it takes many years. For example, most of the drugs that are available, and we'll stick to Parkinson's for the time being, that are available for you today have all been in clinical trials for years before you were able to go into your doctor, have them write a prescription for it, and you go to the drugstore and have them fill that prescription for you. Clinical trials also usually extend anywhere from 5 to 15 years. And there are many phases of clinical trials. Sometimes they get from phase 1, it looks very promising. They get to phase 2, still looks very promising. Get to phase 3, and those are all, I'm talking about from the lab in a petri dish to be tested on animals, and then to be clinical trials available on human beings, etc. Each of those phases can take, as I said, 5 to 10 years. So it takes a long time to bring anything new to market, because obviously we try to make things better for people. We don't want to make anybody worse.
Right.
So it can take a long time. But I think it's really important to have hope, to hang on to hope, for sure. I mean, look what's happened, for example, with the research into DBS. We have lots of information about deep brain stimulation surgery, but the criteria in the last couple of years has changed quite dramatically. When I first learned about DBS many years ago, because it was just coming into its own when I started to work at the Parkinson Society 17 years ago, it was just thought mainly as a last resort for people. In other words, they had to have tried every combination and complexity of various medications in various cocktails, and obviously had to have a lot of things that were not being benefited by the medication, and they had to be spending having only at least 1 or 2 hours of on time throughout the day in order to even be eligible for the criteria of DBS. That's changed a lot for various reasons. And now the criteria, while it is still strict, and while it's not something that they would give to a newly diagnosed individual, it's relaxed more now, and the criteria is different. And people who are not so progressed with Parkinson's, it's now been made available. The other new kid on the block, shall we say, is something called duodopa, and that is an intestinal gel. You have a tube similar to an insulin pump, except this tube, it's like a feeding tube, is put into the small intestine, which is where your medications are absorbed. And then your medication is put directly into that tube. And you have a pump, and it's a continual pump. And so for people who are really experiencing tremendous fluctuations, I'm talking about on periods during the day when your medications are working really, really well, and off periods when medications are not working, it really smooths out those tremendous fluctuations throughout the day and gives you back a tremendous quality of life. So that's another new thing. It's again, you know, you have to have tried various things, and it's not given to somebody obviously who is newly diagnosed, but it holds a great deal of hope and potential as a new. It's levodopa. It's not a new medication. It's just a different way of administering it.
But
And
it's so expensive.
I'm sorry,
But
Charles.
so expensive. You can't get
That
Americans.
is true. It is extremely expensive as it stands right now, but that expense is going to start to be relaxed. There's a lot of advocacy going on in Canada to be able to, and certainly in Ontario, to be able to have it accepted on the insurance plans and to reduce the expense. I agree, it's extremely expensive, but I think what I'm trying to share with you is that in spite of that, there is hope. Research is coming to fruition. And while it may take a long time, um, it's happening and it is ongoing and it's out there and there's a lot to be hopeful about. Peter, would it be okay if I just shared for a second my hope? Okay. I just wanted to share with you, as you've all been told now, I've you know, I'm not a new kid on the block, and I've certainly been dealing with people with Parkinson's for a long time now. And my biggest hope, and I really hope in my lifetime I will see this, is that we will have a medication that we will be able to develop that's what we call neuroprotective. That's a medication that will protect your dopamine cells, your dopamine neurons that are continuing right now to produce dopamine, so that to protect them so that they won't get sick and die. Um, when people with Parkinson's are newly diagnosed, you still have somewhere between 60 and at least between 30, approximately 30% of your dopamine cells are still alive. But usually at least 60 to 70% of those cells have already died off. And right now, we don't have a way yet of being able to prevent that last 20 to 30% of your cells from dying off. They're working very hard on finding something to protect those cells so that they won't die off. Because I'm hoping that in my lifetime, and certainly in yours, that when you go to the neurologist and they say to you, you know, you have Parkinson's, and here's one medication, but here's something that will protect your cells, and it's not going to get any worse. I think the hardest part of living with Parkinson's that I've been led to understand, and I've spoken to hundreds, of course, of people with Parkinson's over the years, the hardest part is the progression. And I think if those of you who have had Parkinson's certainly for some time, and even you, Carrie, someone who's newly diagnosed, if your Parkinson's hadn't gotten any worse than it was right at the beginning, I don't think life would be so bad. Is that a fair comment, Peter? Yeah? Okay.